Good afternoon, everyone. Today my name is Shegun. Okay, like I told you in the introduction before, um, I'll be facilitating the MT 303 factor analysis, and I want to encourage you to, as much as possible, to participate in this particular class. It will help you. It will build your calculus knowledge. It will encourage you. If you want to go to any other field, you can easily go to. So I'll be sharing my screen for so so let's look at the screen now. Then from then we'll be talking. So let's look at the syllabus. So to say, on the syllabus page, we have these contents. We have at this page, we'll be talking about elementary factor algebra. That's a module one. Factor differentiation, gradients, divergence, and core, the line integral, Green's theorem, divergence and tensors analysis. Then we'll be looking at all the factor. All these particular one will also be inclusive. But now let's quickly move into the course content. I have some notes here talking about factors and scalar. So in this case now, we'll be looking into different aspects. Let's look at the definition of factor, and let's look at the definition of scalar. So here we have factors is a factor is a quality having both magnitude and direction, such as we have velocity, we have acceleration, force, etc. And then when we talk about scalar is defined as a quantity having a magnitude but no direction. Quantity, please underline this, having a magnitude but no direction. But if you look at the factor has a direction, but there is no direction when it comes to the issue of magnitude. So let's look at it. What are the examples of this? We have mass, there's no direction. We have length, volume, speed, real number, and any real numbers. So and so on and so forth. But let's look at the component of a factor. Any factor A, any factor A whatsoever that is in a 3-dimension can also, let's look at it, can be represented with initial point. Can be represented at initial point at the origin of rectangular coordinate system. Let's look at the formulas that are involved in this case. We have A dot factor B, which is equals to the absolute value of magnitude value of B, A and B cos theta. So in this case now, what is A dot B? So we need to look at A dot B. Remember that in this case, we have A1, A2, A3, then B1, B2, B3. So, and the A, we now say A dot B will be, this is the dot, will be A1, B1 plus A2, B2 plus A3, B3. So these are the values that we are talking about that represent A dot B here. Then we can now find the angular coordinates, a rectangular coordinate of it. That is, looking at, make your theta from here, let our theta be the subject of formula. When you make theta to be subject of formula, what do we have? then we'll divide both sides by magnitude of A and B. When you divide both sides by magnitude of A and B, so we have it to be in this form, and you find the angular velocity, rectangular velocity in this case. So these are the elementary ones that we'll be talking about, and it will lead us into uh, so many analyses that we look at the examples here and there and see how it can involve in so many things we are also doing. We look at the example, but before the example, let's try and explore as many as possible. So let's look at this. So in this case now we have, but let's look at this matrix. Please note this one. Notes. Take note of this. Look at it. That is, anytime you have I dot j is equals to 0, anytime you have j dot I equals to 0, k dot I equals to 0, well, anytime you have I dot I is equals to 1, that's why we can have in this place to have, that's why we can have in this place to be A1I plus A2J plus A3K. That's why when you find the dots of each of them, that is, sorry, we'll put this one there, B1I, B2J, B3K. So by the time you said A1 dots AB, that is I dot I will give you 1. So that's why you can see this particular one is 1. And this also, and this also, that's why we can have A plus B, A1 plus A1, B1 plus B, A2, B2 plus A3, B3. So let's take note of that. So we can proceed, and we have the law of scalar. The law of scalar says A dot B is equals to B dot A. A dot B is equals to B dot A. That is 2 times 3 is equals to 3 times 2. So that's just a literary example. Then here we have A, M in brackets, A dot B is the same thing as M multiplied by A factor A dot B is equals to A dot B in bracket M multiplied by M, and so on and so any scalar in this case. Then we can also discuss the law if A factor A dot factor B equals to 0, then factor A and B are perpendicular. Factor A and B are perpendicular. So let's take note of this. So we can now proceed by solving the problem. Now, let's look at this definition too before we go into that. Now, at this point now, we're trying to write another definition, which is also one of the key definitions that we need to know. So now when you have A equals to A1I plus A2J plus A3K, the absolute value of it, or the magnitude, is very simple. That is, we have our A to be equals to absolute value. That is, square each of them. That is, find the square root of A1 squared plus A2 squared plus A3 squared. So it's the same thing as R S I plus YJ plus ZK. So let's take note of that. So it will give us something of this nature. Now let's look at this. When you have when you are given how to find this, what do we have? In this case now, we have so many things to fall back on. Now, let's look at this example. So I'm given R, write it here. Let's say, hope you can see the board. So, number one, given R1 to be equals to 3I minus 2J, 3I minus 2J plus K, then R2 will be 2I minus 40J minus 3K. Then R3 equals to negative I plus 2K plus 2J plus 2K. So we are asked to find the magnitude. Find the magnitude of A, the R3, B, R1 plus R2 plus R3. Then C, to find 2R1 minus 3R2 minus 5R3. So these are the things we asked to find. Then for us to solve the solution, we look like this. Remember your R to be absolute value of R to be equals to square root of x squared plus y squared plus z squared. So in this case now that we have this, we can go ahead and solve the problem. How do we do that? Let's pick R3. R3 is the same thing as the absolute value of negative I plus 2J plus 2K. We have it up, so we put it there. Then it simply means the square root of each of them. That is negative 1 squared plus 2 squared plus 2 squared. So what are we going to get in this case? So we have it to be square root of 1 plus 4 plus 4, which is square root of 9, which is equals to 3. So we have the R3 already to be 3. Then we can go ahead and solve for the rest. Then how do we solve for the R1 plus R2 plus R3? So B, under the B, we have R1 plus R2 then plus R3, which is the same thing as what is R1, 3I minus 2J plus K plus 2I minus 4K J minus 3K plus negative I plus 2J plus 2K. So let the all components be together, I to I. Then we can now add at component by component. So the first one is, so we have I to I, 3I plus 2I minus 1I, making 4I. Minus 2J minus 4J, then I have minus 4J. minus 4G. Oh, you don't, okay, let me try and explain better. Let me explain better. This is what I'm doing. I'm just taking 3I plus 2I minus I plus minus 2J minus 4J plus 2J. Then plus K minus 3K plus 2K. So I already have all them component by component. So if I add everything here together, I have 4I. Then plus, if I add everything here together, I'll have negative. So this one will be negative 4G. Since everything is J, here we have plus 0K. So it's simple. Then we can now use this one as we can now find the magnitude value of this. So if I find the magnitude, to find the magnitude value of this, it's pretty simple. All I need is just to say then R1 plus R2 plus R3 equals to 4I minus 4J plus 0K. So in this case now, I have square root of 4 squared plus negative 4 squared, then plus 0 squared, which is same thing as 32, which is same thing as 4. We can now break this one down by saying that we have 16 multiplied by 2. I have square root of 16 times 2, which is 32. I can now say square root of 16 multiplied by square root of 2. So square root of 16 is 4. Square root 2. So this is the answer for, this is the solution for B. So that we can go ahead using the same spirit to do the second one, the third one rather, which is C. Our C value, we need to look for the C value and see what the C value asks for us. For us to get the C value, we have 2R1 minus 3R2 minus 5R3. So in this case now, you have to multiply each of the R by the coefficients. We have 2 in brackets. Our R1 is 3I minus 2J plus K minus 3 in brackets 2I minus 4J minus 3K minus 5 in brackets minus I plus 2J plus 2K. So let's open the bracket, distribute the 2 over this. You have it to be 6I minus 4J plus 2K. Then minus 6I minus 6I minus 12J minus 9K. Negative 5I plus 10J plus 10K. So all I need is to use the same component by component idea. I have 6I here, then I have another negative 6I, So when I open the bracket or distribute the negative over this, then I have positive 5i. Yes. Then plus negative 4j, positive 12j, then negative 10j. Then plus 2k, positive 9k, then negative 10k. So we can proceed by saying that we know what we are doing at this point by saying this is 0, we have 5i, plus, let's see whether it's plus or no. So we have negative 2. This will give us negative 2j. And by the time you add this together, you have 11k, 11k minus this. So that leads us to you have k here. Let's check this one again. K, 9k, and negative k. So in this case, now we have 11k minus 10k, we have positive k. So we can proceed. So then we have our 2r1 minus 3r2 minus 5r3 to be equals to 5i minus 2j plus k. So at the end of the day, what do we have? We're going to find the square root of 5 squared minus 2 squared. 5 squared, okay, put them in the brackets for simplicity, plus negative 2 squared, then plus 1 squared. So at the end of the day, you have square root of 25 plus 4 plus 1, which is square root of 30 rather. Square root of 30. Can we also break down of this? You can check. You will see where it's lead us to. So the next thing we need to look into is if we're given, how do we find unknown value part of this problem? So take for example, another example, if you have number 2, we have if r1 equals to 2i minus j, plus k, and the R2 equals to I plus 3j minus 2k, and R3 equals to negative 2I plus j minus 3k. R4 equals to 3I plus 2j plus 5k. So in this case now, we're asked to find scalar a comma b comma c such that R4 is equals to a R1 plus b R2 plus c R3. R3. So how do we solve this problem? So one of the things we require to do is just to substitute our equation into this problem. So we have our R4 solution now. Don't be confused. We have R4 here, value, substitute the value of R4 here. You know the value of R1, you know the value of R2, you know the value of R3. Put them there, open the bracket, then solve it simultaneously. You find to get A, B, C. They are called your unknown. Then that shows that if you're able to prove that, that shows that it's a linearly dependent on R1, R2, R3. So let's go ahead and see how we can solve this problem. Our R4 is, let's solve the R4. We have it to be 3I plus 2j plus 5k equals A in brackets. A in brackets. 2I minus j plus k plus b in brackets negative 2I plus j minus 3k no, sorry, would be I plus 3j minus 2k. Then plus c in brackets negative 2I plus j minus 3k. Now that we have this, what are the things do we need to solve in this case now? We need two things. We need to open the bracket and see. After you open the bracket, take all the A out, take all the B out, and take all the C out. So after that, you will be able to solve the problem accordingly. So now that we have A, so you agree with me that at the end of the day, I'm going to have something like this. So at the end of the day, I'm going to have 2a, or probably I should open it so that you can see what I'm saying. I will have 2ai minus aj plus ak plus bi plus 3bj plus minus 2bk plus negative 2ci plus cj minus 3ck. So it's going to be 2a plus b minus 2c, all in component of I. Because I just picked this one, or this, then plus negative a, right, plus 3b plus c. A minus 2b minus 3c. Okay. So it is now obvious that we can now match our R4 into each of the I, into the components. So we are going to have 2a plus b minus 2c equals to 3, equation 1. I'm equating into the component of this particular one. So equation 2 will be negative a plus 3b plus c will be equals to equation 2. Then we have a minus 2b minus 3c equals to 5, equation 3. So if you solve this very well, you have solving a to be equals to minus 2, b to be equals to 1, and c to be equals to negative 3. So our R4 now can be, we can now have our R4 to be equals to negative 2R1 plus R2 minus 3R3. So we can boldly say at this point that the vector R4 is said to be linearly dependent on R1, R2, and R3. So let's take notes of this. We can also ask another interesting question. You can ask us to solve the parallel resultant which we already know the way we normally solve the magnitude. So let's look at number 3. We say find a unit vector parallel to the resultant of vector R1 equals to 2I plus 4j minus 5k, and R2 equals to I plus 2j so plus 2j plus 3k. So for resultants, in this case, we need to have, let's solve this problem now. Solution. Let me share the screen. Okay. Put the interruption. Yeah, we have R1 and R2. And don't forget, the solution in this case is very simple. Our resultant, we are resultant to be R equals to R1 plus R2. So we know the R1. Our R1 is 2I plus 4j minus 5k plus I plus 2j plus 3k. So at the end of the day, the capital R, which is our resultant, will be 3I plus 6j minus 2k. So then the magnitude of the R will be in this format, 3I plus 6j minus 2k. Which is the same thing as square root of 3 all squared plus 6 all squared plus minus 2 all squared. So which is square root of 9 plus 36 then plus 4, which is square root of 49. This at the end of the day you have 7. So is that the final answer? No. So for us to find the unit of parallel, so what we need to do is we've already calculated our R, then a unit vector parallel to R is real the parallel R. We have divided by R, which is equals to divided by resultant. We have our normal R, 3 vector A plus 6j minus 2k. Everything divided by 7. So all we need to do in this case is to say 3i divided by 7 plus 6 over 7 j minus 2 over 7k. So, and the rule says, if you find the absolute value, if you find the magnitude value of this particular result must equals to 1. So now let's try and see. So for us to check, we have it to be 3 over 7i plus 6 over 7j minus 2 over 7k, which is the same thing as the square root of 3 over 7 all squared plus 6 over 7 squared plus negative 2 over 7 all squared. At the end of the day, if you punch your calculator very well, you will have 1. So we will also proceed in this case in our next class, but for today we are able to discover the magnitude and the horizontals with a parallel vector parallel. So we're able to show that. And I want to advise you, go to your course materials. All these examples are also in some places there. You can also do some tutorials that are at the back of it. So we will be taking them one step at a time, and we're able to prove all these proof. Also, they are very important. Take your time and learn some of them and able to show them to us under the module. But in the next class, I will also look into some of those the main courses. I will look into some of those law, and like they are trivia anyway. You can easily prove them. They are there. The definition. Look at this one now. How do you do this? All you need to do is just to find the if you want to find the angle. Where do you find the angle? We'll be talking about it in next class, talking about cross products and talking about some of those elements that will be useful in the dot products of two vectors. How do we solve them, and where do we go from there? So we'll solve some of them. Then I will also expose us to some of those the previous questions. Then we can also use them to see how we can get some simple definitions about them. And we check the cross products of two vectors, then I'll find solution to as many as possible in the next class. If you have any questions, you can leave your comments. You can send me an email. I have my email in your inbox. You can send it to me if you have any question concerning today's class. So, and I will try to encourage some of us to also attend the live section If you attend the live section, it's different from that. It's different between textbook and the lecturers. When you attend the live section, you'll be able to ask questions. That what are the things that are not clear to you? You can ask me one-on-one, and then I can go over it again with you guys. And I'm here to assist and put you through. Please, I want you to download the video, watch the video, check your module, and as we honor, National Open University is here to assist you, but try as much as possible to also assist yourself. And I want to, in case you have questions, like I told you, please feel free to drop me a message. Feel free to drop the comments, then I will be glad to attend to those comments. My details are on the announcements on the platform. And if in case you need any clarity on what we've discussed today, don't hesitate, and also share the link among your friends so that the next class will be more than this in the next class, and all of us will be happy to be able to do stuff together. Once again, Shagonke is my name. This is the class for MTH 303 vector and tensor analysis. Let's try as much as possible to help one another by putting things together. And at the end of the day, if you have any question, any comments, please do not hesitate to send them to me. But before we go, let's look at the highlights for the next class. What are the things we'll be discussing? Like I mentioned the other time. So we will be talking about some of the dot products. Then we'll look at, if you look at this, how the product of two scalar products of two vectors, how do we normally multiply them? How do we solve them? How do we find the angle? We also look into how to find the angle. After the dot product, we find the magnitude of each of the vector 2. We also find the angle between the two vectors. Then we also find the cross product of two vectors, and so on. So I have a lot of examples here facilitating that will guide you in your paper and your exams. So on this note, we'll be drawing the curtain. See you guys next class. Thank you. Remain blessed.